Możemy zacząć So, hi and welcome to Indeed about PWAs. Now then, what actually is PWA? Basically, it's a common name for a group of technologies that provide native-like mobile experiences on the web. To properly explain its benefits, I would like to start with a few common web and mobile development, let's call it hiccups. Well, people leave a site if it takes at least 3 seconds to load, at least according to a Google developer survey. Also, web applications tend to perform poorly or actually don't perform at all if your connection is slow or non-existent. Also, depending on the type of your app, mobile development can be slow and usually a bit frustrating. Well, what if you need to ship your application as soon as possible? Also, mobile apps are usually distributed via an app store, which can be a frustrating process if you want to, again, ship it quickly. Well, PWA to the rescue. You can bypass or solve most of these problems quite effectively. And PWA as a platform consists of 3 main kind of advantages, I would like to call them, which is speed, reliability, and engagement. Let's move on to the first 2 then, which are speed and reliability. Speed meaning that you can cache your static resources, which obviously increases your load times significantly. Also, the huge advantage is that you can work offline, so the users don't notice any difference between being offline and online, except for notification. And also, your web application can sync in the background. Well, how do we do all this magic on the front end or JavaScript side? It is done by some service workers, which is basically JavaScript that runs in a separate thread and handles all the caching and offline stuff. We will dive a bit deeper in a few seconds. First, a bit of theory. Usually, when you have a client-server application, you send data or receive data via requests. So here I can call get unicorn, and the network, well, returns a unicorn, which is what I've asked for. Service workers give you a bit more power though, because in their event handlers, you can manipulate the data before it gets to your application. This is nice and all, but it only works if you have a stable connection. So what if I'm offline? Well, with service workers, you can use your local device. The workflow is as follows. I send the request as usual. My installed service worker checks if the application is online, and if not, it draws its data from the cache. And then it returns the data that I wanted. And it serves it to my application. As I said, this is all done offline, so your app's functionality isn't affected in any way. Thus, the user experience is great, and the user is likely to visit your app or page again. Some .NET nitpickers here may object that you could use browser cache instead of all this fancy new JavaScript stuff. Well, you of course could, but there are some drawbacks. Mainly, if you use browser cache, you don't get to take advantage of offline support. Also, you can't customize the data in any way, and you need a bit of a server config. So, what do we actually need to properly implement service workers? Well, we need 2 things, mainly HTTPS and a supported browser. HTTPS, because of service workers, you can easily exploit them if you don't have an HTTPS connection, which can screw your request. So now that you know what it does, it could be good to know how it does all the stuff. The main part of it is the Serviceworker Lifecycle, which consists of 3 main phases. And those are registration, installation, and activation. So let's move on to the first phase, which is registration. The registration phase happens as soon as you open your application. The function checks if your browser is supported, which usually should be because it supports all modern browsers. And if it is supported, it moves on to the next phase. The next phase is the installation phase. Here, you can decide what stuff to cache, and you can also cache it in the install event listener. So here in my constant, I specify URLs with the static assets, meaning the UI static data caching that I've specified. It is recommended to cache only the parts of your app that are a part of your application shell, meaning the stuff that you actually see and that you interact with, like the UI resources of the application. The content, which is called dynamic, is then displayed later. This has a few advantages, mainly in speed, because the user doesn't see a blank page when he opens the app, but instead he sees the UI elements immediately because they are loaded from the cache, and he can quietly wait while the dynamic stuff loads later.
Yeah, sorry, I go down. Up again. Okay, can you hear us?
Can we continue?
Yes.
Yes.
Sorry.
Okay, so there are several caching strategies that you can implement with the fetch event handler. The default one, and also the one I've been explaining prior, is called cache first, which is kind of the best for most use cases. And you don't really need to implement anything else because this is the way it was intended to work in the first place. It may look a bit terrifying at first, but remember, it's just JavaScript that you link to your HTML file. Also, you don't need to implement it by yourself from scratch because, for example, Google offers several templates and also libraries like Workbox, which make your service worker implementation a lot easier. Also, for React specifically, if you're doing React, also, if you're using Create React App, the basic service worker implementation is already there, and you just need to kind of flip the switch to turn it on. So no custom event handlers are needed for the implementation. Okay. Most of the time, I've been talking about static data caching, but what about dynamic data, the content of the application? Well, you could use service workers, but it can make things a bit unstable. It is recommended to only cache static assets with the service workers. Also, for dynamic data caching, you can use external libraries like we use on our project, for example, Redux Persist, React, and Angular, as far as I know. There's one but, though. Yeah. You need to handle, somehow, application updates. Well, you can't cache your service worker because you would get in a loop and get stuck. And also, somehow, you need to update the file with new assets. So this is how the update is done under the hood. And you can either do it manually, or you can let the framework do it for you. So updating the app in the browser, how does the browser react to updates of our data? Well, the browser checks for the updates mainly on page reload when the service worker lifecycle runs. When you get again, here I need to emphasize that you only can have one session of your application open because of the service worker caching. And also it checks for the updates every 24 hours or in the background. Also, again, I need to emphasize, don't cache your service worker file. It's bad. So this is all being done under the hood by service workers, so you don't need to really think about it. It's just a friendly reminder. Okay, when the browser actually checks for the updates, a few things happen. A new service worker is created with the updates and enters the waiting state. You can also have multiple sessions of your application open at one time, which I've mentioned. And some people do it, for example, like Google, with an update pop-up, which is the solution to the update problem. Here's a screenshot of the now deprecated Inbox app, which many of you may know. And basically, when there was an update to the application, you would just hit refresh. A new service worker would install itself, and the page would refresh, thus giving you new content. Here, this is how we handle it in our application. It isn't really nice to look at. We are still waiting for the design. But yeah, it works the same. Here I have a small diagram of how it actually works. First, the browser checks for an update after, as I said, for example, 24 hours. If there's an update available, the service worker notifies the browser, and a pop-up message is shown. When you click on the pop-up message, a new service worker is installed, the page is reloaded, and you get the new content. Credits for this diagram to some random guy on the internet and his blog, I guess. Okay, so that was it for speed and reliability. With service workers, we can easily get offline mode, dynamic data manipulation, and many more. The third main principle or advantage is user engagement. Well, engagement. How do we engage the user himself? In the world of PWAs, it mainly means the app is installable on the home screen. It feels like a native mobile app. It is a first-class citizen on your home screen. And also, it wouldn't be a proper mobile app without push notifications on the web. We can achieve these things via something called a web app manifest, which is a plain old JSON file, which contains basic information about your application, like name, theme, and so on, and also can control the appearance of your application when you launch it from your home screen. Okay, so what does a typical manifest look like? It looks like this. It's a JSON file where you have some properties. I will go through most of them because many of these are required for your application to be considered a PWA. For example, the short name is the name that you will actually see on your home screen. The name is, well, name is kind of self-explanatory. And then you have the icons. Icons is an array of objects, and each object represents one icon in your application. The important thing to note here is that you need to have different sizes for different devices, and you have to add them separately. So separate file for separate sizes. First, on our project, we've been doing it like we had one icon file, and then we just declared separate sizes from the same file, but it doesn't work that way. You have to have different files. So yeah, that's kind of unintuitive, but it's the way it's implemented for now. So no dynamic resizing for the icons. Also, moving on, the start URL. Start URL is the first page of your application that the user sees after he launches it from the home screen. It's one of the required properties if your app is supposed to be a PWA. Then moving on, it's the display property. Display property, at least for me, is the most important one because it controls how your application looks when you launch it. In here, when I define standalone, it means that it hides the browser UI, and you only see the application as a native app. So no browser controls, no nothing. Then we have theme and background colors. These are mostly for Android splash screens, and they define the colors of the splash screen, obviously. Not everything is as awesome, though, on iOS. iOS only partially supports it, and you need to use iOS-specific meta tags in your HTML file. Okay, so here's a quick peek at the meta tags needed, like title, web app capable, which is the equivalent of display standalone, and the link to your icons here, which also you need to define separately. So here is the content, which is the name property equivalent, and the web app capable is basically display standalone. The difference between iOS and Android here, except for the meta tags, is that you also need to specify your splash screens for iOS separately. On Android, it is handled in a way that it takes your 512 times 512 icon and just uses it as a splash screen and combines it with your background color to create a splash screen for Android. On iOS, you have to define it yourself. Okay, now we have everything we need to install the app, but somehow we need to let the user know that our application is progressively enhanced. And there is one tool that can help us with that. The Add to Home Screen pop-up makes this job easy. It lets the user know that our application is a PWA. And I'd also like to emphasize that you don't need an app store here if you don't want to, which was also the use case for our project because the client was unable to install the application or distribute the application via an app store. So that's one of the reasons we went PWA in the first place. So no app store if you don't want to. But first, as with everything in PWA, you need to meet certain conditions for the banner to actually appear. Some of the conditions are your web app cannot be already installed, which kind of makes sense. And you don't need to have an app manifest present. You need to have an app manifest present, with icons, start URL, and the name. When you don't specify the display standalone, it launches normally with the browser UI as a default. Also, you need to serve it over HTTPS because of service workers, and you need to have an service worker installed in the first place. Okay, let's see the banner in action then. I have a GIF of Android installation here. I can type in the URL, open the application in browser, and a pop-up, if all the conditions met, is displayed. I can click on it. The application is installed on my home screen. I can open it, and it looks like a native mobile app. Okay. But what about iOS? Well, I love iOS, but it's not supported yet. You need to implement the banner manually, and also you need to install the application manually, and only from Safari. So here's an overview how we do it on our project. I'll switch to a different screen real quick. Okay, can you guys see it on the stream? I guess so. Okay, so this is the application for our client. In the bottom, you can see the nice.
Thank you.
There's a delay. In the bottom, you can see the app installation banner, which informs us that our application is installable. The way we do it here is that we check if the platform is iOS and if the app is not already installed. The main difference between the Android native application banner and the custom iOS banner is that there is no button to actually install the application. That's why you need to do it manually, because Safari doesn't provide the tools for automatic installation. So moving along with the instructions, I can quickly click on the share button, and a menu pops up with the add to home screen capability. I can add it to home screen, and here are two things interesting. On the left is the specified icon, and on the right is the name of the application. You can also edit it any way you want. Okay, so when I click on add, the app is installed on my home screen, and I can launch it from there. When I click on it, you can see the display screen appears, and the application loads itself, and it looks like a native mobile app. You don't really know if it is a PWA, if it's a hybrid app, or it's a native app. So it's a first-class citizen. You can implement them via service workers, but since they're Android only, again, tak to.
Slyšíte nás? Can you hear us?
Can you hear us?
Wait for it, už to je.
Okay. No idea what happened there, but let's continue. Okay. So the last engagement part of PWAs are push notifications. Just a quick info here, you can implement them via service workers, but since they're Android only, I won't go into much detail. I'm not sure whether this screen dropped, so sorry, I'll just repeat it. If you want iOS capabilities, you can use a third-party service, for example, OneSignal, which also provides the capability of developing our app and turning it into a. And to make sure it works properly, we need to test it thoroughly. For that, there are a few ways which we can use. So you can use it only in the browser and not in standalone mode. So this is something we have been fighting, but on the project it proved not to be a huge issue. The main thing here is Lighthouse audits. Lighthouse audits provides several useful tools to measure performance, to measure accessibility, and PWA issues.
No sound again. Okay. Yeah, sorry.
Can you hear us?
Can you hear us?
Mám pocit, že to padá úplně pri každém
Sound
jiném
okay
videu.
again.
Okay, so Lighthouse. It's an automated tool for web page auditing, and it should be your go-to tool for any performance, accessibility, or PWA issues. It's also accessible via the Chrome DevTools in the Audits tab. It supports also any kind of web pages, and it supports different types of audits, which you can combine as you wish, or at least by your preferences. Let's have a look then. Moving on to a test application that I have here. Can you see it on the stream?
Yes.
Okay, so here I'm in the Chrome DevTools in the Audits tab, which should come as a standard in Chrome. Web checklist, best development practices for the modern web, accessibility issues, search engine optimization issues, and also I can simulate the network. Also, it is really important to clear storage before every audit because of the service worker. Let's run it then. I will choose mobile on this page, and yeah, it's fine, no throttling. Let's just run it. So the app is simulated on a Nexus 5X, and it checks several pages or several parts of your web app, and it should also for example, the performance is for buttons, etc. Also, here's the first painting. Also, here in the bottom, you can check some stuff that you need to check manually. So it provides a lot of useful stuff. Okay, moving back to the presentation. Yeah. So our app is developed and properly tested. Now we need to release it to the user. Here we have two options. You can keep it web only. If you want, you don't have to do all the hassle with the App Store, or maybe if you can't distribute. You can deploy it to Play Store. New, and we don't really have support for iOS yet. It's in development. Okay. As with every app, you need to meet some criteria. Mainly, your app needs to pass PWA criteria that I've been talking about. Lighthouse can help you with that. Also, there's the AD out of 100 performance mark. And also, you need to abide all the current Play Store rules. So, which approach is actually best for your app? Well, that depends on your use case. The undisputed advantages are the ease and speed of implementation. It is also framework agnostic, so you can use it with React, you can use it with Angular, you can use it with Vue, or just plain old vanilla JavaScript. And also, Google and Microsoft are pushing it real hard since, like, I don't know, 2015. Microsoft, for example, released a useful tool called Pwn Builder, which provides a set of libraries that can make your life as a PWA developer a bit easier. Okay, so those have been the advantages. And when you don't want to go PWA, well, you have limited native SDK functionality. For example, you can't access Touch ID. You also, it's not really suited for games or applications that are data heavy because it's not a native app and you will never get the required performance you want from it. And there is also the point about the bad iOS support. The first support for service workers came in iOS 11, and support for gesture navigation came in iOS 12. So it kind of improves each version. but yeah, as you may have seen, it's not really. Yeah, why not? At least according to our application, we had troubles, at least a year back when we started developing it, with bad iOS support until version 12.2. We also used other tools for dynamic caching, for example, Redux Persist. And we've chosen to use OneSignal for push notifications, maybe in the future. Okay, it's not as bad as it seems though, because the web manifest and other PWA things are being actively developed by Apple. So it will only get.
No question from Prague? Or Zlín? Okay.